Hi friends, how are you? Welcome to our channel Tech on Target. Today video will be going to be on Terraform automation and we will achieve Terraform automation via Azure DevOps. So let's start the video. Uh, I am hoping the audience for the video must have some prior knowledge of Terraform. If you don't have that, please visit our channel and there are basic uh, videos on Terraform tutorial in Hindi and English language. Please go and watch, then come back. So, give you some idea about Terraform. Terraform is an infrastructure as a code tool. We can create infrastructure from code by using Terraform. Here we write some configuration file. How we write? That's a different. But we write some file in which that we write some resources, write some configuration. It like what server, uh, what should be its CPU, and lots of stuff are there. We keep it in the Terraform configuration file, and on behalf of this configuration, our infra will be get created, and all this information will be get saved in one file, which we know as Terraform state file. So TF state file. So then we have plan. Why we use plan? We use plan to review the uh, to get review what my configuration file with what it can do, like what resources it is going to create. It gives us the clear view of our code is successful or not, uh, maybe up to 90%. There are some possibilities there, like when we are doing plan, it's saying it's okay, I'm going to create this, but it's also giving that disclaimer, it's not assured that this infra will get created or not. So when we do apply, there might be little chances that that infra get will not get created, that might get some error. So plan is helpful for getting preview. So the now in the Terraform you have to write some configuration file, then to check what it's doing. In reality, you are going to do it by check by plan. Then you have to apply. You apply those configuration to the cloud, and real infrastructure get created on the cloud. Here you can see there are Datadog, AWS, GCP, Azure, and there are thousands of providers are there on which Terraform is working, and it's very successful in creating infrastructure. There are other also options are there, like for AWS with cloud formation, AWS CLI is there. But if I tell you today, as a DevOps, now you are working in Azure, and now after some time you have to work in GCP or AWS. If you are using their own CLI and other tool, it is very difficult, getting very difficult for you to switch. But now you have it, you have the Terraform, you just have the knowledge of the Terraform, how to write the configuration file in the Terraform, and you can easily write different uh, uh, files for different providers. And there are some, might be some scenario in which your client is using one service for one client and some other service for other client. Multi cloud services are there, so you can manage this type of situation very well with the uh, by using Terraform. So I'm hoping that who are new to Terraform are very much clear with Terraform, how it's working. That's a different way, but the general idea or high level idea is clear, I hope. Okay, move to next. To automate the things, we require some CI/CD tool. Like there are very popular tools like Jenkins and others today, GitLab, GitHub, others. There are many, very huge number. But I'm choosing the Azure DevOps, and because it's very getting very popular this time because of its features. Like uh, we will see when we implement this. Uh, it's just like plug and play. working in Azure DevOps. So what Azure DevOps is offering, you can see on screen. It consists of different things, so different services like Azure Pipeline, where we can create our pipeline. Pipeline means number of steps written, like Terraform init, then Terraform validate, plan, apply. These steps will take care by the pipeline. So then we have VCS, version control systems like GitHub, GitLab. We store our repository there. Have we have a solution by name of Azure Repos in Azure DevOps, where we can store our repositories, and then Azure board is there. We can create tasks on that, and we have multiple options there to create docs and wikis there. Then Azure artifacts. Uh, for example, we are generating some files, what our infra will do, and we can save that in Azure artifacts. Moreover, if you are building an application of Java, Maven, PHP, .NET, maybe other, you get, after building the code, you will get some binaries, and where you store that binaries or store the artifact, you can store it on Azure artifacts. It provides different features like versioning. There are many features are there. You can check on that. And there are different test plans there. If you see this, what it's means, like we have a code. We are first doing some planning, and according to that plan, we write some code. Then we build that code, and after that, when we will test that code. And to test that, we go to release, we deploy that, then we check with the operations how it's working, we monitor the continuously it then according to that feedback, again we plan and do some changes in code, again build it, again test it. And it will not like that someone is continuously doing that. Only we have a person who is writing the code, and this process is done automatically. This pipeline will, you can see that it's a not ending, it's a continuous loop. It will remain in continue anytime. It's not getting to break. So that's the Azure DevOps for you. Now we are clear with high level idea of Terraform and Azure DevOps. We can move to next. It's it is the diagram what we are going to do today. What we are going to do, we are making a CICD pipeline in Azure DevOps to automate the deployment of Terraform. So first we have the Azure repo as our VCS. You can use GitHub, GitLab according to your wish. And what we are setting here, anytime when some commits are coming in, maybe in particular repos, particular branch, or you can choose any branch. Whenever commit is occurring, you can put it on merge or different action of Git. But here I am just specifying the commit. Whenever commit is happening on the repo, a trigger is generated on Azure, and what it's doing, it's triggering the Azure DevOps CI pipeline. This part is here up to CI, and it is getting triggered from this commit. Whenever you will do commit, like you are the person DevOps who is writing the code for Terraform. When you are writing the code for Terraform, when you actually writing the code for Terraform and you are pushing it on VCS, automatically the CI pipeline will work. And according to basis on that failure or success of this CI pipeline, our release will work. So, and all reports will get generated. No manual intervention is there. Okay, so nobody is caring. I have to care about to test the code. Testing deployment will taking place automatically. So here my CI is getting triggered. First part, I hoping that first part is clear. You are hosting a VCS with who is going to trigger you whenever a commit is like we use webhook in Jenkins. Same. First step is to check and install dependency, like where we are going to perform the Terraform infra creation process. Terraform should be there. To and as a dependency of Terraform, there we can say if you are working on Azure CLI, if you are working on AWS CLI should be there. Otherwise, Terraform itself can't do much without the corresponding CI. Plus, on that CLI should be authenticated with that. And in the last, we have Docker. Docker is helpful in providing, or it's used to provide the container environment. Why I am using the container environment here, why I'm ensuring this, in this particular step I'm also ensuring this, I should have Docker as a dependency, plus I'm also pulling some images. Which images I'm pulling? tfsec, linting, and cost estimation. Like here you can see that we are pushing the images in the steps, and we are executing some. First step is the dependency and images as a dependency. Then is the execute Terraform init, plan, and validate. Here, if you see Terraform init plan, what I am doing, that whatever VCS we have got as a trigger, whatever code we got, we are initializing the Terraform repository in the agent machine. Then we are checking by the validate, and then we are running the plan. Any of this step will fail, CI will broke at that step, and same if it is fail in plan, validate, same message on Slack, on email will go to dedicated person that you have to do by doing that alerting. We can integrate Slack, your emails is very easily with Azure DevOps. So next is when this step is get completed, that plan is get succeeded, and we have get a report. Then we run Docker images, tfsec, linting, cost estimation, and they perform operation on they will generate logs and cost estimation tfsec. What they do, we will discuss in the next slides. But here we are generating logs, and we will upload these logs to storage. Here we can use Azure storage, we can use other storage as well. Okay, if branch in which code is committed was main, then it will trigger the release. Otherwise, it will just publish the report. Publish report will taken place in both cases. Why I'm doing that? I'm only triggering the release from main, like someone who is working on a feature branch. I don't want every time infra will get affected. So whenever they are certain about their action and they should merge it with the feature branch, then they go for the release. And when release is pushed or triggered, then it will, what it is going to do, it is going to install Terraform init and applying the infrastructure. Apply means Terraform apply, you know very well that it will create the infra there, whatever we written in the source. So this workflow is of CICD is very much clear. We can move to next slide. So to do demo, we have some prerequisites. You should have some active cloud services, maybe Azure, AWS, and Azure DevOps account is must, because we are performing each action our CICD on Azure DevOps. You should have Terraform code. You can create it, just take some time, and you should have a machine which will act as your agent, and on that agent you should have Terraform prior there. And if I tell you, it should be able to communicate with means it should have authenticate with your provider like AWS or Azure. Then you should have Docker installed, because you have to run different images. Then we need a storage account, either it is store a blob or AWS 3. We can use other cloud providers storage also. GCP is also there. There are lots of providers. There are some famous one, so I'm taken that. Here I have tell you that we are going to use these three images. Three images are referring to three tools. What these tools are offering to us, why I'm interested in this. It's offering us the tfsec static analysis security scanner for your Terraform code. Then we have Terraform lint. It's a framework, and each feature is provided by plugin. The key feature are as follows. tfsec is mostly used for security. Then tflint is like syntexual error. It will check some things are getting syntax are getting deprecated. It's tell us to use the best practices and some naming convention. And if you are have declared some variable in var file and in you can say in .tfwats file, it will give you the error like we are not using proper. Then we have infra cost. What infra cost is doing, it will give us the a cost of infra, like we are going to create one VNet with 2 virtual machine. It will give us the whole month estimation, like in this month, in 1 month it will, in 30 days it will cost you around $50. And you can assume that we have already have one VPC, one VNet and 2 virtual machine, and we are going to add a load balancer. So it will also tell us that in current state you are having a monthly bill of $30, and if you apply, you will get new monthly bill as a $50. So here you get two things: cost estimation plus cost difference. Okay. Now we are going to start our CI pipeline. I am hoping that previous what we have discussion done is clear to you. Then we start with part 1. We will install the dependency. We have already discussed about dependencies, like we are going to install the Docker, CLI, install Terraform, pulling required Docker images, different whatever you think that should be present, you can do that. Then if you see that in the Azure DevOps pipeline, it's a YAML kind of file. It's a YAML file. You can check with the syntax. Under that we call some task, and under the task I'm calling the bash task, and passing this just they are Linux commands. You can get this command from their respective sites, like from Docker, from if you go to official website of Docker, you can simply get that. Then from Azure CI in the Azure portal. Same for the tfsec, tflint. There are just commands which you have to run on Linux. Then on part 2, Terraform init and plant. We will implement that. First Terraform init, then validate, then plan. If any of these steps is fault, CI will get breaked, and you concerned person will get the message that this particular CI is getting broken because of this error. Okay. In this part, if everything will remain fine, we are passing a flag of -out equal to plan.out flag to make this file to change in a file, in a text file, which we can store for our reference for future. Okay. This is the task in the Terraform which we can write and run. here in the last tfsec linting at part 3 we have pulled some images of docker, and we according these images will do some operation on that. Now at third part we will apply. Why I'm applying this at third, not at first? Why I'm not testing that? Because up to Terraform plan we have checked, but if it's not succeeding in Terraform plan, there is no meaning of applying that checks, because now we are thinking that our code is ready to be ready to execute uh, in the release. So before going to release, we do some checks for security, because functional wise we are going to achieve the same, like, but if we are hitting for the aiming for the virtual machine, it will create virtual machine most probably. But there are some like security threats which will check by this tfsec, some syntax problem, some uh, best practices, some variables, and there are lots of things. Then whatever the cost we will get, just like you apply that, and after that, after 1 month you get bill of $2,000. Then everyone going to blame you. So this file will tell you, maybe you have called the much resources, and they are going to they are going to make you cry, because they are very costly resources, and somehow you are going to choose, you are going for the standard, but you have go to premium, and it are going to cost you very high. So they are very important to run in a very consistent environment or consistent system, and very healthy system. So here the steps, or we can see in the we have to mention this step in our Terraform Azure's pipeline. After that, those steps, we are adding the Terraform tsec and running the command. It will generate the required file. Same, we are going for linting and cost estimation and cost difference. And after that, here we are generating the logs for tfsec cost file and cost difference file. And after that, when these files are getting generated, we are going to upload that on here you can see that on blob I am going to upload. So in the same way, our in this way our CI is getting completed. So till now, if you have some issues, you can go back and check that. And up to this checks, our CI, if our CI is getting succeeded, we will get some like here in this step of Fiverr, we are files which we are just what we can generating artifact. In the artifact we are publishing it, and when we publish it, it will going to store here. And in our release pipeline, we are triggering it from this. Whenever we get this release, we can run this release. So here we can mention here one our repository, and we can trigger from repository whenever we have a repository commit in the main branch, and same ISC, both things are available, then this action should run. You can see that it's auto trigger action, and if you see that it's have 3 tasks. These 3 tasks are that it will checking the Terraform is there, it will initialize Terraform. If you're seeing that we have already initialized in the CI, and we are now, because whatever it initialize, it will clear the workspace. Whenever CI and it will clear its workspace, so you will not find Terraform in it there. So that's why we save all file. So again, now we have to initialize it, then we have to apply it. When you apply, then you will find that infra what you was targeting to achieve, you will get that. Either it's AWS, Azure, whatever is that, your infra is ready. So CI plus CD with desired checks is completed. What is missing? If there is Terraform apply, we should be able to destroy whenever we want. Like this particular service is now not needed in my organization, so I should be able to destroy. To destroy that, I need Terraform state, but I'm saying that whenever release or CI run, it will clear its workspace. So we have your blob storage. On that we have created our backend file in our Terraform code. According to that, it's getting moved on that blob storage, and state file is there. If we go here, is the manual approval. First I clear the step. It will check for Terraform, then it will init the Terraform, and it means initialize the Terraform, and then it will go for the destroy. Means everything which you created by this infra will get destroyed, but it will never. Here you can see that it is not auto triggered. It will never run. Plus you can do one thing, like you have a team lead, team owner, whatever project lead you have, you can mention its ID, like that. If this particular person is approved, only then this particular step will run. Otherwise, like me and other people are in my team, if they are going to approve, they will not going to get this approve option. So manual approval required for that particular person from their person user ID. When it's approved, Terraform destroy will run and destroy the whole infra. So we are clear with CI plus CD plus its additional tasks. So I like to thank you for joining us. Please subscribe, share. Thank you. Bye.